Concept 5 is on density. So what is density? Density is a measurement of how closely the particles in a substance are packed. Okay, so when we talk about density, we are basically saying if the particles are very close together or if the particles are very far apart. High density means that the particles are very, very close, and if we have a low density, then the particles are far apart. Density is specifically a ratio of mass to volume. Now, if you remember from math, we can write a ratio in fraction form. So what we would do is put mass on the top and volume on the bottom. Okay? A substance with lower density will float on top of a substance with higher density. So, for example, oil and water, we know that oil would float on the top and water is on the bottom. Okay, and what that means is oil has a oil has a lower density and water has a higher density. Okay, how do we calculate density? The formula for density is D equals M over V. D is density, M is mass, and we measure mass with a balance. It can be a triple beam balance or it can be an electronic balance. The unit for mass is grams, always. Okay, V stands for volume, and we measure volume with three things: a ruler, a graduated cylinder, or a pipette. Okay, and we can also use a syringe sometimes. All right, there are three possible units for volume. For a solid, it is generally cubic centimeters, or cm cubed. Okay, for a liquid, it is usually in liters, which is a capital L, and for a gas, it is usually in milliliters, which is ml. Alright, now I like for you guys to go ahead and draw the formula triangle. Some of you might have used a formula triangle before, and some of you might not have, but this is how it works. We put m on the top since it is on the top of the fraction, and D and V are on the bottom. And this triangle will help us solve density problems. Okay, now there are a few units for density. Since we have 3 units for volume, there are 3 possible units for density. Okay, I'm going to write them over here. Density units that are possible. Since we have grams on the top and cubic centimeter on the bottom for solid, it will be grams per cubic centimeter. Okay, liters on the bottom, then it will be grams per liter. And if milliliters on the bottom, then it will be grams per milliliter. Okay, and one other thing that I want you to know is that cubic centimeters and milliliters are the same. Okay, they're equal to each other. Alright, let's look at examples. We are going to use the 5-step method to solve the problems. Okay, number 1. 100.00 grams of a liquid completely fill a 200.0 milliliter bottle. What is the density of the liquid? Okay, so first step is what are the givens? Notice that in this case we have 2 givens. We have 100.00 grams, which is our mass, and the volume is 200.0 milliliter. Okay? Second step, the answer that I'm looking for is how many grams per milliliter. This is the density. Okay? Alright, the third step is the formula, and I'm just going to draw the formula triangle because that's going to help me. Okay, we are looking for density, so the way that you use the triangle is you cover up density in the triangle, and that tells us that you need to take mass divided by volume. D equals m over v. Okay, I'm going to put the fourth step over here. The fourth step is really just plugging in the formula. We are not going to do a grid this time. Okay, so the mass is 100.00 grams over the volume, which is 200.0 milliliters. Okay, put this in the calculator. 100 divided by 200, and you should get 0.5 in the calculator. Now, sig figs are important, so let's look at our sig figs in a given. Okay, we have 100.00, that's 5 sig figs, and 200.0, which is 4 sig figs. So my answer should have 4 sig figs. So it's going to be 0.5000. That will make 4 sig figs. Include our units, grams per milliliter, and box up the final answer. Look at number 2. Number 2 says if a block of copper measures 2.00 centimeters times 4.00 centimeters times 5.00 centimeters and weighs 356 grams, what is its density? Okay, if you remember from geometry, you know that this is the length times the width times the height of the block. Okay, so our given in this case is we have the mass, which is 356 grams, and we also have the volume, which is 2.00 centimeters times 4.00 centimeters times 5.00 centimeters. Okay, and that is equal to 40, and we need 3 sig figs, so it'll be 40.0, and since we multiplied centimeters 3 times, it's going to be cubic centimeters. Okay? The second step, the answer that I'm looking for is the density, and the density is going to be in grams per cubic centimeters. Third step, I'm going to draw that triangle again. Mass over D and V. Okay? I'm going to cover up D again because I am looking for density, and it looks like I have to take mass divided by volume. So D equals M over V. Fourth step, we're going to plug in the numbers. So D equals 356 grams over 40.0 cubic centimeters. Okay? I'm going to put this into the calculator. 356 divided by 40.0, and I got 8.9. Now we need 3 sig figs because both our givens have 3 sig figs. Okay, so it's 8.90 grams per cubic centimeters. And that's our final answer. Alright, I'll do one more with you. Let's look at number 3. Number 3 says a solution has a density of 1.50 grams per milliliter. How many grams are needed to obtain 10.0 milliliters of the solution? Okay, so our givens are the density, which is 1.50 grams per milliliter, and it looks like we also have the volume, which is 10.0 milliliters. Okay, and we are looking for the mass. And mass is always going to be measured in grams. Okay, third step, again, draw the triangle. And this time, instead of covering D, I'm going to cover M because mass is what I'm looking for. And it looks like I have to take D multiplied by V. So that would be density times volume. So the fourth step is just plugging in. Mass equals 1.50 grams per milliliter times 10.0 milliliters. Okay, and I want you to look at the units. Since we have milliliters on the top and milliliters on the bottom, they can cancel out and we will have grams left. 1.50 times 10.0 is going to give you 150, and we need 3 sig figs, so I'm going to add a decimal point to make that 3 sig figs. Okay, and that's in grams. That is the answer. I want you to do number 4 by yourself before you come back to class, and let's move on. Okay, there's one last thing that we need to talk about when we talk about density, and that is specific gravity. Specific gravity is a ratio that compares the density of a substance to a reference, okay, at the same temperature. Now the reference substance for liquids is usually water, and water has a density of 1.00 grams per milliliter. Okay, so we would put the density of the substance that we are curious about on the top and put the density of the reference on the bottom of a fraction. Okay, and remember the reference is water in most cases. Okay, there is no unit for specific gravity because what's going to happen is we have grams per milliliter on the top and grams per milliliter on the bottom, and both of those will just cancel each other out. Okay, specific gravity of a liquid is measured with an instrument called a hydrometer. And this is what a hydrometer looks like. Here it is. We have basically a graduated cylinder, and we put the hydrometer inside the graduated cylinder, and the graduated cylinder is filled with water. That's our reference. Okay, we would get a hydrometer reading where the meniscus is. Okay, basically we have a liquid that is inside the hydrometer, and that will tell us how that liquid compares to water.